Hello students, how are you all? I hope all of you are doing amazing. Welcome all of you at AriserTalent, and I'm your physics teacher Krina welcomes you all. So, in our previous lecture regarding the physics of chapter light and reflection, what we have dealt with? We have basically dealt with the image formation by the convex and concave lenses. Now, in today's lecture, we are going to discuss about the very important formula, that is our lens formula. But before that, we have to know about the power of the lens. We have also seen about the power of the mirror, but now we are going to discuss about the power of the lens. Then we will learn a very important formula, that will be our lens formula. So firstly, we are going to deal about the power of the lens. Now, the power of the lens is actually the measure of deviation produced by the lens. It means how much deviation a lens is able to produce is simply given by its power. So, we can say that it is the measure of deviation produced by a lens. So, the measure of deviation produced by lens will be given by its power. Now, how you will denote the power? We will denote the power simply by P. And its formula will be 1 upon small f. And what is small f? Small f will be the focal length of that particular lens. So, P will be given by 1 by f. Now, the P will be in diopters. It will be in diopters. So, diopter is actually a unit for measuring power. And what will be the unit for focal length? The focal length will be considered in the unit, that is meter. Focal length will be in meter. So, this is the formula for calculating the power of any lens. Now, what is the condition here? Now, what will be the condition here? So, we have actually two conditions here. Firstly, if I am talking about the power of concave lens and the power of convex lens. So, we have the two type of the lenses, and previously we have a discussion that the focal length in case of concave lens is negative. The focal length is negative in this case. If f is negative for the concave lens, you can see that the power will be negative for the concave lens. So, power came out to be negative in case of the concave lenses. So, this is an important thing. Now, convex lenses. Convex lenses will having a positive focal length. If the focal length is positive, you can see that the power came out to be positive. So, the power will be positive in case of the convex lenses we have. So, the power will be positive. So, simply you have to learn that in case of the concave lens, you will have a negative power, and in the convex one, you will get the positive power. Now, this is the whole thing about the power, but one thing you have to keep in your mind, if you are taking the combination of the lenses, it means if you have two lenses placed in close contact with each other, then what will be the power of both the lenses? The power will be the sum of the individual power. So, here this is a very important note to remember. So, just keep it in your mind. If lenses are placed in close contact with each other, if lenses are placed in close contact with each other, then the total power of both the lenses will be the algebraic sum of the individual powers. So, the total power will be given by P, and it will be P1 plus P2. It means this power will be the algebraic sum of individual power. So, simply you have to just add the powers. So this will be our algebraic sum of individual powers. Now what will about the focal length? If I am calculating the focal length, so 1 upon f came out to be 1 upon f1 plus 1 upon f2. So this is the condition you are getting if you are placing two lenses in contact with each other. So just keep this note in your mind. Now, this is the whole thing about the power, and the unit of the power we have is diopter. Now, we are going to deal with a very important topic and a very important formula in this chapter, that is the lens formula, and definitely a numerical question is going to ask from this formula. So now let's start the lens formula, but before that just copy this from here. Now, let us deal with her lens formula. If you know about our previous lecture, we have a discussion about the mirror formula. So just like we have a lens formula now. The mirror formula is actually give you a relation between u, v and f. Now what is that u, v and f? F will be the focal length of the lens now. U will be the distance where the object is placed, and v will be the place where the image is going to be formed. So again the lens formula is giving you a relationship between f, u and v. So lens formula is simply giving a relation between u, v and f. Now the lens formula is 1 upon f is equal to 1 upon v minus 1 upon u. One thing keep in your mind that in mirror formula we have a plus sign here, but in the lens formula we are having a minus sign here. So 1 upon f equal to 1 upon v minus 1 upon u is our lens formula, where f is the focal length, v is the distance of image, and u is the distance of object. And where these distances must be calculated? These distances must be calculated from the optical center of the lens. So this is the whole thing about the lens formula. Now we have one more formula just like a lens formula, and that is known as the lens maker's formula. So the second thing is about lens maker's formula. Now what is lens maker's formula? This formula is 1 upon f is equal to mu minus 1 upon r1 plus 1 upon r2. So this is the lens maker formula we have. Instead we are having 1 upon r1 minus 1 upon r2. Now what is this mu? Mu is the absolute refractive index. And this mu will be written as n of air upon n of vacuum. So this is mu in this case. So this is the lens maker's formula, and this is simply our lens formula. So a numerical is definitely going to ask in your exam dependent upon both these formulas. So let's solve a very simple numerical problem that is based on this formula. So let's have some examples, so it might be clear to you that how this formula is applied and what will be the sign convention we are using on solving the numericals. Now let's see what first example is showing. A concave lens has a focal length of 15 centimeter. So firstly, I am writing the given conditions here. What is given in the question? The first thing is you are given with a concave lens. You are given with a concave lens. The focal length is 15 centimeter. It means f will be minus 15 because the focal length in case of concave lens will be the negative one. What distance should the image of the object from the lens be placed so it is forming an image at a 10 centimeter from the lens? It means you have to identify u here. What you have to find out? You have to identify u here. And what is the v given? V given in the question is 10 centimeter. So again, v will be minus 10 centimeter for the concave lens. So these things you have to keep in your mind, that what sign convention we are following for solving such type of the questions. Now, you have to find out the value of u and also you have to find out the magnification produced by the lens. So we have discussed about the magnification produced by the mirror, that is given by the formula, that is height of the image upon height of the object, or it is given by minus v by u. So similar formula we are using in case of the lens, but here the magnification will be v by u. So firstly just apply the lens formula and try to find out the value of u here. So what I am doing, we are applying lens formula. Now, what is the lens formula? Lens formula is 1 upon f equal to 1 upon v minus 1 upon u. Now, what I have to determine? I have to determine the value of u. So, I am taking u in the left hand side, and what I am doing? I am just replacing f here. So, 1 upon f will be shifted here with a negative sign and 1 upon u will be shifted in the left side, and this will be our formula now. Now, what is the value of v here? V here is minus 10 centimeter. So, it is equal to minus 1 upon 10. What is the value of f? F is minus 15 in this case. So, it will be equal to minus 1 upon 15. And it came out to be minus 1 upon 10 and minus plus and 1 upon 15. Now, LCM of 10 and 15 will be 30. 30 will give you 3 into minus 1 plus 15 and 30 will give you 2 and it is equal to 1. So, what it came out to be? It came out to be minus 3 plus 2 upon 30 and it is equal to minus 1 upon 30. And 1 upon u will be equal to minus 1 upon 30. So, I can say that u will be minus 30 centimeter. So, where the object is to be placed? Object is to be placed at a 30 centimeter to get an image at a 10 centimeter. So, you can find out the value of u by simply using the lens formula. Now, you have to determine the magnification produced by the lens. So, in this question, one thing you have to determine is small m. Now, the formula for magnification is simply v by u. So, magnification is denoted by small m and it is having a formula that is v by u. Now, what is the value of v in the question? V is minus 10. V is minus 10. And what is the value of u? U, we have find out that u equal to minus 30. It came out to be minus 30. Minus will be cancelled by minus, 0 will be cancelled by 0, and I am getting here m equal to 1 by 3, that will be equal to 0.33. So this is what? This is the magnification produced by the lens. So this is the magnification you have calculated and this is the value of u we have calculated. Now, we have to determine the two things in the question. Firstly, you have to identify the distance should the object be placed from the lens. So the distance came out to be 30 centimeter, minus 30 centimeter. And what will be the magnification produced? Magnification produced came out to be 0.33. So you can see that how by applying both the formulas, we have solved the numerical. But what you have to remember? You have to remember the sign conventions we are using for solving such kind of problems. So just note down this problem from here because it is very, very important part of the chapter. So just copy that part. Now, let's move to the next question in this sequence we have. Let's see what the second question is saying. A 2 centimeter tall object is placed perpendicular to the principal axis of a convex lens of focal length 10 centimeter. So firstly, again I am writing the given conditions. What is given in the question? The question is saying the object is 2 centimeter tall. So what is given? You are provided with the height of the object. Height of object, that is small h, and the object is 2 centimeter tall, is placed perpendicular to the principal axis of a convex lens. Now which lens is given? We are just talking about the convex lens in this case. We are dealing with convex lens. The focal length is 10 centimeter. So the second thing we are given is about the focal length, and the focal length in this case is 10 centimeter. Now, the distance of object from the lens is 15 centimeter. So, how you will denote the distance? The distance of an object from the lens is simply denoted by the small u. So, the distance of object will be denoted by u and it is equal to 15 centimeter. Now, the sign convention you have to remind that in case of convex lens, you have to take the value of u negative. So, u will be your minus 15 centimeter in this case. Now, you have to determine the nature, position and the size of the image and also the magnification produced. So, what things you have to find out? You have to find nature, position, size of image, and also you have to determine the magnification produced in this case. So, how many things you have to determine? 1, 2, 3 and 4. So, 4 things we have to determine. So, firstly what we will do? We will just apply the lens formula and find out the distance of image from the lens. So, I am just applying here the lens formula. Now, what is the lens formula? Again, lens formula is 1 upon f equal to 1 upon v minus 1 upon u. This is our lens formula. And what we have to find out? We have to find out the value of 1 upon v. So, we can write here 1 upon v will be equal to 1 upon f plus 1 upon u. So, this is our lens formula. Now, on substituting the values, you can see that the focal length is 10 centimeter. So, it will be 1 upon 10 plus u is minus 15 centimeter. So it will be like this. Now 1 upon v will be equal to 10 and 15. Again give you the LCM 30. So what I am getting here? 3 into 1 minus 2 into 1. And what it came out to be? It came out to be 1 upon 30. So what will be the value of v from here? V will be 30 centimeter. So where the image will be formed? The image will be formed at 30 centimeter. So we have calculated v in the first part. Now, we have value of u, you have value of u and v, and what you have given? You are given the length of the object. Length of the object is given to you. So what will be the formula for magnification in this case? So magnification in this case will be given by m is equal to h dash upon h equal to v upon u. This is the formula for magnification we have. What is h dash? H dash will be the height of the image. And what is h? H is the height of the object. So I can write here h dash upon h is equal to u upon v. V upon u. Now h dash will be equal to h into v upon u. Is it all right? We have just shifted the formula. Now height is 2 centimeter, v is 30, and you can see that what is the value of u here? U is minus 15. U is minus 15 in this case. Now on solving this, we are getting h dash equal to 4 centimeter. What we are getting? We are getting the value of h dash equal to 4 centimeter. Now, this came out with the negative sign. So, you can see that the image form will be real and inverted in this case. The image form will be real and inverted. Why it is so? Because the magnification came out to be negative here. So, image will be formed, will be real and inverted in nature, and you can see that the image will be magnified. And how much the image will be magnified? The image will be magnified, we can calculate simply by using the formula, that is v upon u. So, m will be v upon u. So, what is the value of v here? V is 30. And what is u? U is minus 15. And magnification came out to be minus 2. So, magnification is minus 2 in this case. So, I can see that the image form will be real and inverted. And where will be the image formed? The image will be formed below the principal axis, and you will get the enlarged view of the object. So, what things we have calculated from here? That image will be real and inverted. And where will be the image formed? Below principal axis. And what will be the nature of the image? The image formed will be enlarged in this case. So, these are the things we have to find out, and we can see that the magnification produced here is negative. So, the image will be the real and inverted one. So, this is how you can solve the numerical problems that can be asked in your exam, that is related to your lens formula and magnification. So, the question can be asked in your exam by combining both these parts. So, what you have to remember? You have to remember the lens formula, you have to remember the formula for magnification, and you have to learn the sign conventions also for solving such type of the problems. So, this is all about the lens formula and magnification. This lecture is over here. We will deal with many more topics in our next lecture. Thank you so much and have a nice day.